Right, welcome everyone. Let's look at the standard UK main supply. We label it 230 volts AC, but if you were to connect an oscilloscope to those pins, you wouldn't see a steady line at 230. You would see this, a sine wave oscillating 50 times every second. Crucially, look at the peak voltage, V0 or V peak. It's not 230 volts. It is actually reaching approximately plus and minus 325 volts. So if the peak is 325 V, why do we call it a 230 V supply? And more importantly, if we want to calculate power dissipation, the heat generated in a resistor, which value do we use? Crucially, look at the peak voltage, V0 or V peak. The voltage is only at that peak for an infinitesimal instant before dropping back down, passing through zero and reversing polarity. The average voltage is technically zero, but the average power is certainly not. The bulb gets hot. We need a single, steady number that represents the heating effectiveness of this constantly changing wave. To find this effective value, we use a statistical operation called the root mean square. To understand it, we must perform the operation in reverse order. Square, mean, then root. Step 1. We square the voltage wave. If we used the peak voltage of 325 V in our power equation, P V square over R, we would be massively overestimating the energy transferred. Step 2. We take the mean, the mathematical average, of this squared wave. For a sine wave, this average happens to be exactly half the height of the squared peak. Step 3. To get back to units of volts, we take the square root of that mean value. This new level is the RMS voltage. This is the definition you must know. The RMS value is the value of steady DC voltage that would produce the same average power heating effect in a resistor as the AC source. For a sinusoidal wave, the math dictates that the RMS is the peak divided by the square root of 2. 325 volts peak divided by root 2 gives us roughly 230 volts. That is why we use RMS for all AC power calculations. Since power is proportional to V square, this makes all negative voltages positive. Want to dive deeper in physics? Do like and subscribe to Physics Unbox.